Okay, so welcome back to Computer Science 305. This is the third part of the first Prolog lecture. And in this part, we're going to be talking about operators and lists. And so just like any other language, Prolog has some predefined operators, right? And you also have the ability to define new ones. Operator here is just simply a predicate with a special abbreviated syntax support. And so if we have, we can use, like, for example, the equality operator to test if two things are equal, and it only will succeed if x and y can be unified. So, for example, if we want to run, we can check if the parent Adam Seth, if the parent predicate can be unified with parent Adam and then some variable x. So in other words, we're asking, is there some way to unify and bind the variable x such that these two become equal? We run that, and of course x, if it's bound to Seth, makes these two equal. Furthermore, with the abbreviated syntax, we can do this in an infix way. So say parent Adam Seth equals parent Adam x, and if we run that, we get the same result. But note that in reality, it's just calling the original prefix approach of doing this. Similarly, for we have the arithmetic operators, so we have plus, minus, times, and equal, and divide, which have their usual precedence and associativity. So we can say x equals plus 1 star 2 3, and we go ahead and run that, and it shows us that it is equivalent to 1 plus 2 times 3. So we can also write the same way. So x equals 1 plus 2 times 3, and get that. But note that this is not evaluated, right? And furthermore, we also need to be aware that even though it prints it in the abbreviated form, it's actually storing it in the prefix notation way. So bear that in mind. We also have to note that it's not this term is not actually evaluated. So we can't unify, for example, 7 equals 1 plus 2 times 3. These are not going to be the same, right? Because 1 plus 2 times 3 was not evaluated. It's just a piece of data sitting there waiting to be as a fact. And so there is a way to do this, and we'll talk about that later, but we're not going to talk about it right now. We just want to you just need to note that we have these terms and they are considered to be predicates. We can, on the other hand, say plus xy, right? So we have the plus operation. We can unify that with 1 plus 2 times 3, and we get 1 for x and 2 times 3 for y. So bear that in mind. The next part of this is talking about lists. And so lists and Prolog are very similar to ML lists. In that, and we have the Adam, the empty square brackets represents the empty list, and so we can have a predicate. We also have the predicate dot, which corresponds to ML's double colon cons operator. So if we were to write an ML expression, we have the empty square brackets. It's equivalent to the Prolog term empty square brackets. We have one double colon cons with the empty square brackets is the same as saying the predicate term, the Prolog term dot, followed by in parentheses 1 comma square brackets. We can also say 1 double colon 2 double colon 3 double colon empty square bracket is equivalent to the dot 1 comma dot 2 comma dot, and then in 3 comma square brackets, all those separate parentheses. Now, interestingly enough, we can also put in any other terms, for example, parent xy, which there's no equivalent. We can do that in Prolog. We can't do that in ML. So we also have list notation, right? So we can build up a list as we expect. And we get the term out of that would be what we see on the left hand side. So sorry, the left-hand side has the list notation. The right-hand side has the term that is actually denoted. So we get the ML style notation for lists, but we have to understand that these are just abbreviations for the underlying term, which uses the dot predicate. And also note that Prolog will display this notation for lists. So if we want to run an example, if I can get out of this, okay, there we go. So if we were to run this as an example, we can say x equals 1. We're building up the list 1, 2, 3. And that with a dot, and it gives me a whole bunch of errors for some reason. I can rerun. I have no idea why it's doing this. It's very annoying. Let's just see if we can get a square bracket out of this. 2, 3. Oh, and okay. I'm not sure why it is giving me errors for the dot notation, so I'm just going to assume that there's some issue with the CSCI Prolog on Linux, so let's just utilize the square bracket notation for now. I want to see if this one works. Yeah, it's giving me some weird errors. Let's not worry about it for now. We'll just say x equals 1, comma, y equals 2, 3. Let's see what that does. I know that's going to... Oh, and it gives me that. Okay. Anyway. So we can also, apparently, you can say last in list can be the symbol, the vertical bar followed by a final term for the tail of the list. It's useful when we want to define patterns, because, for example, if we were to put in the square bracket 1, 2, followed by the tail x, right? And we can ask, is that equivalent to 1, 2, 3, 4, and 5? And in fact, we'll unify x with the tail of the list 3, 4, 5. We can also use the append predicate to build up a list, right? We can say append, and we can have 1, 2, the list followed by the list 3, 4, followed by some variable z, which will then say, so we're appending those things and storing them in z, if you will, which then gives us z is you've been bound to 1, 2, 3, 4. So the predefined append xyz succeeds if and only if z is the result of appending list y onto the list x. So, very good, right? We can do a little bit more. It's not just a function, right? We can also unify, so we can say append, and then we can have the variable x 3, 4, and then followed by the list 3, 4. Hello, and then z being the end result of the append process. If we have 1, 2, 3, and 4, then x will unify with the list 1, 2, right? And it does. So append can be used with the pattern of instantiation, that is, with variables in any of the positions, but it's still not just a function, right? We can have, for example, we can append and then have variables for x, y, and we get 1, 2, 3 as our end list, right? And then this will give us various, all different permutations of x and y, ending with, so it'll go through all possible combinations thereof. So we can implement append ourselves, right? So we can say append takes in the empty list, b. So we do that, right? We can say append. We can give it head as a variable, followed by tail a, b. Oh, sorry, and empty square bracket. And then we can say b followed by head, and then tail C, and we can define this predicate such that we can have append tail A, B, tail C, and that should be the definition, right? And that, of course, gives me a failure. I'm really getting kind of tired of that. I'm not going to try to figure out why it's giving us problems. Okay, beyond that, we have some other predefined list predicates. So we have member, select, nth, and length, right? So provable. So we can ask if X is a member of Y. It's provable if the list Y contains the element X. We have select, where we're selecting X. So we're selecting, it's provable if Y contains the element X and Z is the same as Y, but with one instance of X removed. We can look up from the nth item starting from 0. So if X is an integer, right, Y is a list, and Z is the X element of Y counting from 0. And then finally we have length of XY, right, provable if X is the length of Y. So all these are flexible, just like append, and queries can contain variables anywhere, right? So for example, if we want to use select, we can say select 2 from 1 to 3 Z, right? So this is going to say we're going to select the second item from the list 1, 2, 3, right? Starting from 0, of course, and assign that, and we're going to try to unify that with Z. So doing that will give us 1, 3, right? And there's no other possibility. We can then select two items from Y, such that they are 1, 3, and that should give us a whole bunch of different possible permutations. Oh, my bad. We'll try that again with a period, and it'll give us all possible different permutations. So we can also reverse a list, right? So we can say reverse 1, 2, 3, 4 Y, and that will assign to Y the reverse of the list in the first predicate, the first term in the predicate. And so it's pretty simplistic. I'm not going to go into the attempting to do the implementation. We'll see a more interesting implementation later. Actually, why don't we give it a shot? So we'll say reverse, take in 2 empty lists, and then we can say reverse head or tail. I'm assuming that this may or may not work. And then we can say reverse tail Y and append Y head X. Yeah. I need to go and deal with some of these things. Oh, sorry, that's why it's giving me a problem. I actually have to load this from a file. Let's try a new file. Reverse. So we'll actually redefine that. Shut up. Shut up. Okay, let's try this again. Okay, so we have that defined. Let's go ahead and say consult reverse. Looks good. All right. Oh, dot. So now it's giving me I have no capability to do that, so it probably will fail. Let's call this reverse. We'll call it 2. Maybe we'll try it again. All right, now it comes in. So then we can define reverse X and then 1, 2, 3. let's call it reverse 2. It's going to be real slow. Yeah. So anyway, non-terminating queries, right? So if we did this, actually exactly like we did, it would cause problems. Ask for another solution, cause an infinite loop. For theirs, they hit Control-C to stop it, then A for abort. Reverse cannot be used as flexibly as append, right? So if we were to try that again, so we said reverse, just the regular reverse, x 1, 2, 3. It will give us that. If we try to get more than that, it gives us false. Let's see if we do add in 4, if it'll give us the stack flow. Try it again. Now, I'm assuming that eventually we'll have to call for an action. Anyway, regardless, ideally predicates should be flexible like append. Flexible predicates tend to be are more declarative with fewer procedural quirks to consider, but inflexible implementations are sometimes used for efficiency or simplicity. For example, sort would be, which can be used to sort a list, right? If we were to say sort 2, 3, 1, 4 on X, what this is saying that we want to, X should be the sorted variant of the provided list, right? We run that, it gives us 1, 2, 3, 4, nicely sorted. If we try to figure out from X, what would be the sorted list? So this essentially, if we were to do this, it would give us all possible permutations of the list that were unsorted, including actually the sorted version. The problem here is doing this is a little bit too difficult, and so it's going to say it would not be very efficient to try to figure out how to pull that off. So it's going to tell us because it's not a common task, something we normally would not ask for, it's not going to do it. That's fine. We also note that there's an anonymous variable. So the variable underscore is an anonymous variable. Every occurrence is bound independently of every other occurrence. So bear that in mind. It's very much like the underscore. It matches any term without being from ML. Matches any term without being without introducing any binding, right? So it's essentially a throwaway variable. So we could say, for example, tail of, and then have the underscore, and then some a that then returns a. Sorry, we'd actually have to define this. Anyway, but regardless, we could construct that and say tail of head a, right, which would give us a problem. Furthermore, if we were to define a function like append here, we'll call this append2. Append 2 dot or append.pl. And then in here, if we were to define this append and load that up, we say we actually have to save it, and we call for we'll make that because it gives us errors if we try to redefine things. So if we call and load append, right? It's going to give us this warning here. It says singleton variables detected. So it says tail under little c and tail big C are singleton variables. We need you be aware not to ignore that message. That's basically telling you that you introduce variables you never use. And in reality, we're trying to use the tail little c, but we really meant capital C. So this is most likely means that you misspelled a variable name. And so you need to fix that because this is the only warning that Prolog will actually give you. So if we fix it and we reconsult that, it comes back, no singleton error, and we can then go ahead and run append2 and not have a problem. And finally, I'm going to stop here and we will pick up at part 4 of this.